I just hope that yes, maybe it is recording. Okay. So before I get there, let me just take this. Here, hope this works. No, it just doesn't work. Okay. Anyway, so let's say that we have these many classes. What are those? We have water body. Okay, we have water body. Then we have agricultural land. This is for the best understanding. Okay, agricultural land. Then we have barren land. Then we have built up land. And then let's take another, maybe mining pit or mining area. Then we will take waterlogged area. Let's say some waterlogged area is also there. Okay, so there are, let me just adjust it. I hope this is legible. Okay, so these are the different classes that we have, and let's take them and transpose them over here as well. So transpose. Okay, and I'm just adjusting it back to here. All right, I hope you're comfortable with this. Tell me if you have understood what I have actually done. A B C D E. All right, tell me if you have understood this. Give me a thumbs up if you have understood what I have done. Okay, all right. So let's go back to this. We will take the same problem. 13 1 1 2 1 2 3 4 5 6 13 1 1 2. All right, so we have 13 1 1 0 2 0 0 2 0 0. Okay, so that means I had total how many? I had total, let me just make a auto sum out of this. Okay, so I had actually 17 of them on this. So I had 17 water body samples, out of which 13 have shown correct. Okay, 13 have shown correct. Let me just make one more. So these are the classified results. Okay, these are the classified results, and these are the ground truth data. Okay, these are the ground truth data. Okay. This is the ground truth data. There's a way to do that. Uh, this must have something to do with okay. So this is true ground truth data, and this is classified data. I'm not able to show you ground. All right. Then coming back, just copy this 396010. 396010. And then next we have 0016200. 0016200. 8, then 000 1300. 1300. It just strike me now that maybe we can do a hands-on. That will be better. Then it's all 0, 15. And rest everything is 0. Okay. Then we have 15, 001. All right. This is also 15. We have 0, 0, 1, 0. Sorry, 0, 0. I'll just get this back, okay? This row, I will bring it back here so that you're able to see the diagonal. Let us color this diagonal. We will color it with some light blue color so you are able to see that these are the correctly classified numbers, okay? These are the correctly classified numbers. Tell me if you're comfortable here, until here, if you're comfortable. Okay, all right. So now what we are going to do is we are going to find out that the total number of pixels at row as well as at columns. This is what we are going to do. How do we go about doing it? We will take an auto sum in this direction, okay, and we will also take an auto sum in this direction. So total there are total actually 17 water body samples were taken, out of which only 13 were correct. One was misclassified, another one was misclassified, and two more were misclassified. That is four were misclassified. Okay, which means in our classified results, water body has 16 pixels, but out of which only 13 are correct and 3 are incorrect. This is what it means. In fact, 4 are incorrect in the truth data, ground truth data, and in the classified results, 16 are there, out of which 13 are only correct and 3 are incorrect. Okay, tell me if you have understood this. The row sum and the column sum. Have you understood this? Okay, this is all added together. These are the total number of samples, okay, out of which only 13 were correctly classified. These were misclassified, and this belonged to a different class altogether, showed up as water body. So we are finding 3, but the problem is one more is missing. So for example, see here, out of 13 pixels, 4 were wrong, 3 we are getting, though they are misclassified ones, three we are getting, one more is balance, one more is in balance, so we are balancing it. Though these 4 were wrong, 3 were coming from a different class, no? So our otherwise if we were to look at it, it feels like only one is wrong, because 3 we have taken from some other. I hope you are understanding this. Tell me if you are understanding this. See, 4 I have gone wrong, but though I have gone wrong, to counter them, I have 3 more. Actually, they belong to agriculture, but then I have my results have misclassified them. So 3, 1, 2, 3, 4. That means one is in balance. Okay, one, that particular accuracy still we are not getting. Now, what the Kappa coefficient equation says, it says that in order to find kappa coefficient, you need to know what is your observed accuracy. So what is our observed accuracy? It is the sum of all these diagonals. Sum of all these diagonals. So let's see what is our observed accuracy. What is our observed accuracy? It is sum of all these diagonals. So I'm holding on to the control button and I'm taking a sum of these diagonals only, which is 81. Okay, this is the observed accuracy. Tell me if you are not understanding anything. Okay, observed accuracy. I will share this particular table also with you. This is the observed accuracy. And what are the total points? What are the total number of points? total number of points is sum of all these. Either you can take all this or you can take all this. Both of them are going to come to the same sum. Okay. So sum of all these. Not this 81, okay? Because this 81 is the observed accuracy. So these are the total points. Total points were 98, out of which 81 were correctly classified. So if I was to take a straightforward accuracy out of this, then what I will do to find out just accuracy? Okay, what I will do? I will simply go for 81 divided by 98, okay, and then multiply it with 100. So 82% accuracy I have received. Correct? No. I told you that you have to have 85% accuracy. But right now it is giving 82% accuracy. A little lower, but fine. I have understood what is a direct accuracy. But what I want to do is I want to go for a statistical accuracy because there are some balances. For example, 4 pixels have gone wrong out of 17, but 3 have still shown up in my results. See, these are classified results. So that means what? If I negate it with this side to this side, that means one balance is still there. 4 have gone wrong, but 3 extra have shown up. That means what? Out of 17, I am getting 16 water body pixels. So what if 3 are wrong? Because the statistical result is correct. In place of these 4, these 3 are showing up now. One is not showing. That's all. So similarly here also you will see actually agricultural points were 19. Okay. But what is showing is 10 only. What is showing is 10 only. That means 9 are wrong. 9 are wrong. That is what it means. So Kappa coefficient is a statistical accuracy. It talks about the whole area into consideration, not just about those points. So let's find out Kappa coefficient. Now, in order to find Kappa coefficient, we have already found observed accuracy. Let us find out what is expected accuracy. Okay. All right. So, in order to find out expected accuracy, it is a little tedious process, not very difficult. Believe me. What do? We multiply the uh, row total of water body with the column total of total body. What we do? We just multiply it. Okay. So we will just copy this yet again. Control C, Control V. What we are doing? We're just multiplying the row total with the column total. That's all that we are doing right now. Okay. So what do we do? Row total of water body multiplied by column total of water body. Simple, no? Then again, for agriculture, again, what we are doing? Row total of agriculture multiplied by column total of agriculture. Column total is classified result total. Okay, and this is ground truth total. So ground truth total multiplied by the classified results. Tell me if you are understanding what I'm doing. At least the arithmetics what I'm doing. Okay, so it is 18 multiplied. I can just go for a double click as well. Then built up, just doing it, built up with built up, and then waterlogged multiplied with waterlogged. Okay. I went wrong somewhere. This is correct. This is correct. Built up is correct. Waterlogged. Okay. So this should be I7 and this should be G9. It should be G9. Okay. And then let me just see if it is correct. Yes, it's correct. And then we have waterlogged multiplied by waterlogged. So this is our first step in order to find observed accuracy. Now what do we do? For finding out the observed accuracy, I'm sorry, not observed accuracy, expected accuracy. To find out the expected accuracy, what am I doing? I'm taking a sum. Okay, I'm taking a sum of all this. Okay, I'm taking a sum of all this, and then I am dividing it with square of total points. So total points is 98. So I will have to take a square of this. Okay, I'm just being on a safer side and putting this in a bracket. Okay, and then I'm raising it to 2, or I can also go for just multiplying with it with, okay, itself, multiplying it with itself. What is that? That is 98. Okay, so this is my expected accuracy. What is that expected accuracy? It is 16%. So I have to also multiply it with, if at all that is what I want. Okay, so this is the expected accuracy. Now, besides this, I also have observed accuracy, which is 81. Just give me a second. Okay. All right. So this is the total observed. No, sorry, this is not total observed accuracy. Just give me a second. I think I have not divided it. Sum. Okay, that is total correct points are 81, and in order to find out observed accuracy, I have to divide it with this total number of points. What we have done for accuracy, so it comes to around 82.6, but we have to not multiply it with 100, so that we get something like that of 0.84. Okay, so our observed accuracy is 0.82, and let me just remove this, okay, because it creates issues. So the observed accuracy is 0.82%. In terms of, I hope you are still with me, you are understanding. Are you understanding what is happening? Or give me a thumbs down if you are not understanding what is happening. Are? Okay, so observed accuracy is total correct points divided by the total points. Total points is 98. See, if I add all this, no, I don't have to add all this again. Okay, so when I add all this, it comes to total 98 points that were originally I was with, out of which 82 points were correct. Okay, or 81 points were correct. So this is the observed accuracy. Now, in order to find out kappa coefficient, what am I doing? I am taking observed accuracy. Okay, this is the formula. This is the formula. Observed accuracy minus expected accuracy divided by 1 minus expected accuracy. Actually, this expected accuracy is chance. By chance, 3 more have added. Like that. Instead of 4, 3 more have added. So statistically, it is being conserved. That total results are being conserved. So observed accuracy minus expected accuracy. Then we will just put this in a bracket, no, to be on a safer side, and then divide this with 1 minus the expected accuracy, which is 0.16. That means it is 16%. 16% is accuracy which is added by chance. This is what it means. Okay, and then kappa coefficient accuracy is 0.79. Are you understanding this? Tell me if you have understood how did I go about doing this. We will take up some questions. You tell me what exactly this is and where exactly you are facing problem, and then we will talk about it. This is row total. Okay? This is row total. These are row totals, and these are column totals. I'm just calling them column totals and row totals so that you understand that it belongs to the row. So actually they are what? They are ground truth totals. They're actually ground truth totals. Row totals are ground truth totals for each class, and column totals are um, classified results total for each class. This is what it means. Let's just give them different colors. Yes, I'm looking into it. Wait, I've not read the question. So this is row total. This is column total. Let's just give it a slightly different color and maybe put them all in a box. Okay. Repeat the last part after multiplication of row total. Yes, sure. So, okay. So here what we have done, we have taken row total and we have taken column total. I believe until here we have understood. Observed accuracy is what? Observed accuracy is what is the correct one, that is a total of sum of all these diagonals, okay, which are correctly classified, divided by the total number of points. Total number of points is you can either take a row total sum of these row totals all, or you can take sum of these column totals all. Okay, but just don't take it twice, because this will also be 98, this will also be 98. So then what we have done, we have just divided it with this total number of points that were actually there. Some of them were perfectly classified, how many, when you take a sum of these and then divided by the total number of points, it is 98. So that gives us the observed accuracy. Okay, that gives us the observed accuracy. I believe this you have understood. Now we will talk about this expected accuracy. Now this expected accuracy, no, is very simple. What we do, we multiply the row total of that class. For example, which is the row for water body? It is this. What is the row total there? 17. And then we have column also of water body, which is 16. So we multiply column of water body with row of water body, column total of water body with the row total of water body, and we write it here. So what for water body, we have 17 multiplied by 16, that gives us 272. And then for agriculture also 19 multiplied by 10, that gives us 190. Similarly we go for barren row, barren column, both multiplying together, then built up row and built up column multiplied together, mining column, mining row, whatever that total is multiplied together, waterlogged as well, waterlogged column total and waterlogged row total, both of them multiplied together, we are getting 40. So this is our total. Now if I want to find out what is the expected accuracy, then this is the formula. What is that? We take a sum of all these multiplied values that we have taken, that is a row total multiplied by column total for each of the class. We take a sum of all these, okay, and then divide it with squared total points. What is the total point? All these, no, total points is 98. So 98 into 98, that is square of 98. We divide the sum of all these row total multiplied by column total with that of the square of the total points, and that gives us the expected accuracy. Now what exactly this expected accuracy is? It is by chance it has come right. That means what? You see here, there are water bodies which are 13. Which language will you be comfortable in? English is still my second language, and I feel that I have exhausted out of all the ideas, all the ways in which I am framing what I'm telling you. ये देखो, ये water body का 17 pixels है, 17 pixels of water body, है ना? ये वाटर बॉडी का 17 पिक्सल्स, मतलब 17 पॉइंट्स में लिए थे फील्ड से जो वाटर बॉडी का थे। लेकिन अभी क्या हुआ, ये वाटर बॉडी का बस 13 ही करेक्टली वाटर बॉडी दिखा रहा है। एक जो है वाटर बॉडी का एक्चुअली वाटर बॉडी का पिक्सल था, लेकिन वो एग्रीकल्चर में दिखा रहा है। और एक था जो एक्चुअली वाटर बॉडी का था लेकिन बैरन लैंड में दिखा रहा है, और दो थे जो वाटर बॉडी के थे लेकिन वो अभी वो माइनिंग में दिखा रहे हैं. दैट मीन्स 4 आई एम गोइंग रॉन्ग विथ आउट ऑफ 17. 13 करेक्ट हो रहे हैं, 4 गलत हो रहे हैं. बट ये जो क्लासिफिकेशन में करे उसमें 3 एग्रीकल्चर का भी वाटर बॉडी दिखा रहा है. मतलब टोटल पिक्सल अगर इफ आई एम काउंटिंग टोटल पिक्सल जो मेरे को मिलने चाहिए वो 17 थे, लेकिन अभी तक 13 मिल रहे थे, लेकिन अभी ये रॉन्ग होके 3 और मिल रहे हैं एग्रीकल्चर में से, है ना. So in total I should get 17, but I'm getting 16 because 3 of them are coming from agriculture. Which means what? अभी इंस्टेड ऑफ 17 मेरे को 16 करेक्ट मिल रहे हैं. अरे ये जो अभी एक रॉन्ग हुआ ना उसको जाने दो, लेकिन वो दिखा तो रहा है ना, पूरा टोटल पिक्सल में वो दिखा रहा है. विच मीन्स व्हाट? आई एम गेटिंग चांस फैक्टर एक्यूरेसी ऑफ these 3 पिक्सल्स. चांस फैक्टर, बाय चांस मेरा वो करेक्ट हो रहा है 3 pixels. Now that is what I want to know. What is the mean of that chance factor accuracy? The chance accuracy which is there, no? By mistake or by chance it became right. Became right means what? Statistically it became right, not actually in place. Okay. So considering that expected accuracy, which is chance accuracy, I should also call it, okay, which is 16%, 16.5% almost. And my actual accuracy, if you remember, it was some 82 or something like that, 82 or 83, something like that it was. Then I want to know what is the actual accuracy. I want to neglect this expected accuracy. I want to get rid of that by chance whatever accuracy came, and I want to know what is the correct accuracy. That is kappa coefficient accuracy. So this kappa coefficient, in order to find it out, we have this particular formula. If we have found out expected accuracy and observed accuracy, then the equation goes like this. It is observed accuracy minus expected accuracy divided by 1 minus expected accuracy. That gives me kappa coefficient. Now if you see, my accuracy is coming to 0.79. So what is the interpretation that I should be making? I should be making my I should be making my inference based on this particular table. 0.7, no? So it is substantial. You see, it is falling in this 0.7 something. So it is falling in the substantial, okay, or good agreement, not perfect agreement, but good agreement. My classified results is having a good agreement with that of the field data. This is what it means. Okay. So that is to do with the problem. I will be sharing this particular Excel sheet itself. I will share. That will be better, so you can go everywhere and see what all is being multiplied and things like that. And if you have your own, anytime if you happen to get your own data, confusion matrix data, maybe out of classification, then you will be able to use this particular thing. Just mind that here it has gone a little ulta and here as well. I will correct it and then maybe send it to you if at all I felt that is something that can be done. Okay. So that is it about accuracy. Oh, thank